So in this session, we will see what is the Gaussian or a normal distribution, right? So it is a very important concept in statistics, and especially when you are talking about the outliers and when you are generally checking the distribution of your data, then it is really important to understand what is the normal distribution or a Gaussian distribution. So let's say here I have this, this is the x-axis, and you can see that let's say I have a sample data which is distributed in this way, right? So if let's say there's a data, I have this data which has this mean, right? This point is what we call as a mean, or there could be median or mode, right? Let's say in our case, this is mean, right? This point is mean. Now the data which is normally distributed, how you can like identify it? You can see that this curve, this is basically known as a bell curve, right? What it's called? It's called a bell curve. If you see this bell curve, then this bell curve represent the normal distribution, right? You can see this is a symmetrical, right? A symmetrical means that you can see that if this is your mean, this is center point is your mean, then the amount of data that is present on the right side of this distribution is equal to the amount of data that is present on the left side, right? So the amount of data that is present here on the left side is equal to the amount of data that is present on the right side. So it is a symmetrical. And if your data is in this form, then you can easily say that your data is normally distributed, right? I hope you understand this. Now, why are we using this, or why do we have to learn this? Because using the normal distribution, where we can drive some of the conclusions, right? We can drive many conclusions using this normal distribution. What type of conclusions I will tell you later in the video. But for now, I just make you understand some more concepts related to this. Basically, another thing I wanted to add here is that this normal distribution, if your data is normally distributed, let's say your data is normally distributed, then it's follow a rule which is known as empirical formula, right? So it follows this empirical formula. What is called this empirical formula? Now, what does this empirical formula means? It is basically a 68, 95, and 99.7 percentage rule. It is that simple. It is, what is this? It is 68, 95, and 99.7% rule. Now, what does this rule says? What does this empirical formula says? Let me explain you in detail. Now, let's say I just redraw this diagram over here. And let's say I have this mean over here, right? I have this mean and I'm just creating this normally distribution. So you can see that this is a bell shape and my data is normally distributed here. Let me just point something like I have this. This is my mean, right? This is my mean here. And this is my first standard deviation, right? So this is 1, this is 2, this is 3. Again, this is 1, this is, let's say 2, this is 3, right? Now, let's say this is my mu. Mu means this is a mean. So mu is represented by mean, right? Let me just write it here. This is mu, which is, let's say you have a mean, right? This is a mean. So this is your mean here. And if I just plot this thing, this is my first standard deviation, right? So basically these points are standard deviations. This is first standard deviation, second and third. Let me just draw this first standard deviation. And just like here, I just draw this with green line. And if I do this here also, right? Now, what does that mean? This first standard deviation, this is my first standard deviation. This is my first standard deviation, right? First STD. Now, what is this empirical formula of 68, 95, 99.7 rule says that the area here, the area you see here, this whole area contains 68% of the total distribution, right? So if your total distribution is like 100%, then this area only contains the 68% of the total distribution of the entire distribution of your data, right? This simply says. Again, I wanted to map another thing here. I want to explain another thing. That is, this is your mu, and this point, how you gonna calculate this point? This point is basically your mu plus standard deviation. This is mu plus 2 standard deviation. This is mu plus 3 standard deviation, right? Again, similarly, here you can calculate mu minus standard deviation. This is mu minus 2 standard deviation, and here it is mu minus 3 standard deviation, right? So this is how your standard deviation is calculated, right? Now this area contains your 68% of the total distribution. Now if I just make another line here and your second standard deviation, so this one is your second standard deviation here. Let me just draw this here, right? So the area between these two, you can see here, this area, this total area. So this total area between this second standard deviation is equals to 95%, which means that 95% of your total distribution lies in this region, right? It also adds this region also, the first standard deviation region also. So this whole region contains 95% of your data. First standard deviation contains 68%, second is 95%. If I talk about the third standard deviation, let me draw this with blue, right? And let me draw here. So this is your third standard deviation. So the data, let me just draw this. So this whole region from the third standard deviation from the right side and the third standard deviation from the left side, this whole region contains the 99.7% of your data, of your total distribution, right? So your normal distribution contains these three things. The first is the first standard deviation. It contains the 68% of data. At the second standard deviation, it contains 95% of data. At the third standard deviation, it contains 99.7% of data, right? So this is basically what you have is the empirical formula here. I hope you understand this concept. So I hope you understand this concept right here. Let me just draw this if you wanted to. This is your third standard deviation. This is your third standard deviation. Basically, this is your third standard deviation, and this was your second standard deviation. Okay. Now I hope you understand how this empirical formula is applied to your normal distribution. Now let's just solve an example, right? Let's just solve an example. Let's say I have this normal distribution. Right, where I have, this is your 4 mean, right? So I'm just writing here some sort of things like our mean here is 4 and standard deviation is equals to 1, right? Our mean is 4 and standard deviation is equals to 1. So what does that mean? That this is, if this is my mean, right? This is my mean. Then on the right side, on the first standard deviation, I have this 5, right? And again, this would be 6. And again, this would be 7, right? If from the left side, I have this mean and the standard deviation is 1, then what we'll have is 3. And this would be at 2. And this is 1, right? So this is your normal distribution and these all are your values, right? Sorry. So if we have to calculate the like 4.5 standard deviation, if I say then this is the value 4.5 and you have to find out at which standard deviation this value is present, this 4.5 is present. Now it is easy to calculate it, as I have estimated like 4.5 will be around something here, right? So how you gonna calculate it? How you're gonna calculate it? That's where we have a z underscore method, like you can say z score method. Z score method. What does this z score method means? You have a xi minus mean divided by standard deviation. So this is a simple formula to calculate the standard deviation of any number, like at which, if you have been given a number just like this 4.5, you can easily calculate that at which standard deviation this point is existing, right? So easily you can calculate it here. Just put it the formula here, like 4.5, you can say minus what is the mean here? This is 4, and divided by standard deviation, which is equals to 1. So I got like 0.5, right? So this is a 0.5. So you can say that 4.5 is at the 0.5 standard deviation from the mean. So if you add 0.5 to the mean, you can get this value 4.5, right? I hope you understand this concept. Now it's similar to like if you say like calculate this for 4.75, so you can calculate it easily for 4.75. Just put the value here 4.75 minus 4, and then eventually you will get the 0. Let's say 25, right? 0.25, right? So at 0.25 to the right side of the mean, you can get this value 4.75. So you can easily calculate this 0.25 value, right? Now what if I apply z-score to all of these values? So I have this distribution that I actually discussed before, and what if I just take the z-score of all of these values? How? Let me just tell you here. So let's say I have this, I'm just creating this dictionary here. So 1 minus, you already know the z-score formula here. This is the xi, that means your value minus mean divided by standard deviation. So this would be like 1 minus 4 divided by 1. And again, for the second value, 2 minus 4 is divided by 1. And 3 minus 4 is divided by 1. And similarly, 4 minus 4 divided by 1, 5 minus 4 is divided by 1, and similarly so on. You can just calculate it. So our final dictionary would be somewhere like this. So our final values would be like minus 1, sorry, minus 3, minus 2, minus 1, 0, 1, 2, 3, right? So this would be your final answer after this, after applying z underscore method, right? So your normal distribution, this normal distribution or Gaussian distribution would be around this minus 3. This would be minus 2. This would be your minus 1. Let me just make it a bit. So after calculating the z score of each of the value, you will get these values, right? So your initial data of this is now converted into this, right? So this, when you convert your normal distribution after the z score, this is your new result, right? This is your new result. Now this is called as, now this one is called as standard normal distribution. This is called the standard normal distribution. And one of the main properties of this standard normal distribution is that in this case, your mean is equals to 0 and your standard deviation is always equals to 1. Now this is the main property of the standard normal distribution. So if an interviewer asks you that how you can convert the normal distribution into a standard normal distribution, then you can easily calculate the each of the numbers of the z score of the each of the numbers, and then you can convert it here. So it will be like this. So it would be like the mean should be equals to 0 and the standard deviation must be equals to 1. So this is the main property of the standard normal distribution. You may be thinking like, why? Okay, this is standard normal distribution we have converted. Why do we convert it? Why do we have to convert the normal distribution into the standard normal distribution? What is the reason? Why are we doing this? So this is a really good thing if you are thinking like this. So let's just see this some practical example here. Right. So I have this weight, I have this height. Right. So age would be calculated in years. You know, age is calculated in years. So its unit will be years, right? Its unit will be years. All right, so this is height. Height would be around like feet. Let's say this is around feet. And weight. Weight is your calculated in kgs, right? So it is a value. So it is a units that are here. And let's say I have this data. Let's say 22, 23, 18, let's say 16, let's say 31. So this is our data of the ages. So these are calculated in years, right? 4 feet. Let's say it is 5 feet, 6 feet. Let's say it is 7 feet, and this is also 5.5, let's say. And here I have this weight data, and weight data is like you can say 65 kilos, 95 kilos, 76, let's say 56, let's say 45, right? So this is your data, age, height, and weight. So if I wanted to standardize it, right? So I will calculate the z-score of all of the values that are present in this age column. So I will apply this z-score method on all of these values in this column. Again, for this values, also for these values. So I'll apply the z-score methods to all of these in order to standardize these things, right? So standardize these things means in order to make them standardized, in order to make them like in a standard normal distribution. This method is called standardization. This is called standardization, right? So it is the most important thing while in a pre-processing technique, one of the main pre-processing techniques in your machine learning while you are pre-processing your data. So sometimes you need to standardize data and sometimes you need to normalize data. Now, normalization of the data is quite different from standardization. Let me just also explain you what is the normalization looks like. Normalization and the standardization of the data is quite different. So normalization basically means to convert all the values between 0 and 1, right? So normalization basically means to convert all the values that are present here in your 0 and 1, right? In a range of 0 and 1, right? So for this in Python, we use like min-max scaler. Using the min-max scaler, we just calculate this thing and to convert all of the values in a column in a variable and make them in between the range of 0 and 1. It allows you to provide the lower bound and the upper bound of the data and convert all the values between them. So this is basically a normalization, right? So I hope you understand what is the standardization. Standardization is nothing but basically applying the z-score to all of the values here in order to make them standard normal. And for this normalization, we just convert all the values between the 0 and 1, right? Because most of the machine learning models work on the normalized data. It is suitable to feed them the normalized data, right? So it performs better on the normalized data, right? So this is basically a difference between standardization and normalization. One more thing that I wanted to discuss in this session is the Z-table. Z-table is really important. And for that, let me take an example to explain this. Okay, so this is one of the interview questions that arises related to the z-score, and it says that what percentage of scores falls above 4.25? What does it say? So first you have to select what is the 4.25. Where is 4.25? 4.25 lies here, right? So I just wrote it here. So let me just, this is 4. 4 is your mean in this question. You can say your mean here is 4 and standard deviation is equals to 1, right? And 4.25 lies here. So I just make here like this, right? So 4.25 is here, and what you need to do is what percentage of the scores, these are the scores, falls above. Above means greater than this point on the right hand side, right? So let me just draw if I can. This is, so we are concerning about this region, right? We are concerning about this region. We need to find out that what percentage of values are present in this region, right? In this region. Now, how are we going to calculate it? That's really kind of simple thing. First, what you need to do, you need to calculate the z-score for the 4.25. So how are you going to calculate the z-score for the 4.25? What is the formula here? That z-score, you know, it is xi. What is this? 4.25 and minus 4 divided by 1. So it is equals to 0.25. So 0.25, you got this value, right? Now you got this value 0.25. So 0.25 is your standard deviation, which means that 4.25 is a 0.25 is standard deviation to the mean, right? So this is your standard deviation. Now what's next? What's next is that let me just explain you one more thing here. Let me just explain you here. Now this region that as I highlighted here, this one is known as the tail. What is it called? A tail, right? This one is known as a tail. Let me just put it aside. And this one is called a tail. And this one right here, this complete region, I highlighted with the green, including this part, including this part, this is known as your body. What is it called? This whole region is known as body, right? This one whole region is known as the body. This one is called the tail. Now, you got this value 0.25. What's next for you? You have to see this value in a Z table, in a table known as a Z table, right? So you can easily find it a Z table on Google. This is the ztable.com website, and you can find it here. This is the one, is the Z table here, and you can see that find values on the left of the mean in this negative Z score table. And so all of these values that you can see are on the left side of the table. So try to remember that all of these values that is present here, and there is another table right here, this one. So there are basically two Z table, right? So there are basically two Z table here, and these two tables represents the percentage of the values that are present on the left side of the mean, right? So it represents the values that are present on the left side of the mean. So what did we calculate it here? We calculated 0.25. Now this 0.25, how you gonna calculate it here? So you have to just search it here on 0.25. So you there is two types. This is the negative Z table and this is the positive Z table. You got the positive 0.25. So you're gonna see here that this one is 0.2, and in this is 0.25, right? So you have to check from the Z column. This is the 0.2, and corresponding to this, you have to go to the 0.5, right? 0.05. So it will, if you just add this 0.2 and 0.05, it eventually makes 0.25. So what you have to do here, let me just break it down for you. So you have to just take 0.2 and check it on a Z column, and you have to take this 5 or maybe the 0.05 and you have to check on that column, right? So 0.2 here and 0.5 in this. So you got this 0.5987, right? 0.5987. So you got like the final value is 0.5987, right? You got the 0.5987. Clear? Are you guys clear till now? Now what is this value? This value, remember what I'm trying to say, this value represents the total percentage of data. This value 0.59 represents the total percentage of data that is present on this body, that is present before the mean, before this point, right? 4.25. Before this 4.25, the whole data present here is around approximately equals to 59.87%, right? 59.87%. So this is the whole value present here. So you identified how you can identify this, the whole percentage of values that is present on this side, right? But what was my initial question? My initial question was what percentage of scores, what percentage of values that falls above 4.25, right? What percentage of values that falls above 4.25, which means that you need to find out that how many percentage of values that are present in this side, right? You have to find the values that are present here, but you find it the total values that are present in this region. Now, how you gonna find out the values that are present in this region? It is quite simple. What you need to do, once you have calculated this value from the Z table, it's quite easy. You just only have to do, what you have to do is subtract it with 1 minus 0.5987, right? What you just have to do, 1 minus 0.5987. So you have to just calculate it, 0.5987. So you can get 0.4013. So this is your final answer, 0.4013, right? So this value, let me just mark it with the orange, mark it with this respective color. So 0.4013, this value represents the data that is present in this region, right, on the tail region. So it says that in a tail we have like 40.13% of data, right? 40.13% of data that is present in this region, right? So it is quite simple. Once you got the value from the Z table, it will represent the total data that is present on the body. And when you subtract it with 1, you got the value, or you got the percentage of the data that is present on the right side of the distribution, right? And on a tail side, right? So I hope you understand the concept till here. Right now, again, one more thing I wanted to discuss here is that now we have just calculated this side of the data and this side of the data. What if another thing? I'm just a little bit. This question is completed here, right? This question is completed till here. I'm just modifying one more thing. Now let's say I have. Now let's say the interviewer asks you, okay, this is a 4.25. Let me know how many values, what percentage of values are present in this region, right? So how many percentage of value are present in this region? So you have to like find out the values, the percentage of values that are present between 4 and 4.25, right? So how are you going to calculate it? Okay, so how you're going to calculate it? So the thing is simple. First, you need to calculate the z-score. You got the 0.25. And again, you check the z-score table here. You check the z-score table here, 0.25, 0.5987. You got like 0.5987 here. We subtracted till here, right? Just ignore this one. 0.5987. You got the 0.5987. Now what you have to do? This 0.5987 represents all of the values, including this region also. Including this region also, right? This region is also included in 0.5987. Now, I need to make you understand here that this is the normal distribution. This is the standard normal distribution, which means that yes, this curve is normally distributed. This curve is symmetric, which means that corresponding to the mean, this 4 is a mean, the total data that is present left side of the mean and the right side of the mean is 50-50%, right? Is equal. That means if this whole distribution is represented by 100, then this side of the data, this is 50% of the data, and the right side of the data is the 50% of the data, right? So what I'm going to do, I have to just find out that this value, right? This value. And I got 0.5987, which represents the total distribution, the total amount of data that is present in this region, including including this blue side of the region. Green and blue total combined will give us 0.5987. But we only need to calculate this blue region, right? So what I have to do, I know that this green region is actually a 50%, right? This green region is actually 50%. So what I have to do is I have to just subtract it with 0.5 minus 0.5, right? So I have to just subtract it with the 0.5, and what will I get? Let's say 0.5987 minus 0.5. So I got 0.0987. So this is the 0.0987. So this is the 0.0987. 0.0987. Right, so this percentage, so this is the 0.0987, which means that we have this 9.8%. So what is a conclusion here? Then 9.8% of data, right? 9.8% of data lies in this blue region, right? I hope you understand this, that how you can calculate this, the data on this region, 9.8, right? So this is all of the calculations right here. And I hope you have understood this question. I hope you understood the concept of the z-score, how the z-score is calculated, how you can see this z-score table here. It is quite easy, and I hope you understand this. If you have any kind of questions, then you can definitely ask me. Till then, thank you so much.